Everyone, it's time to look at the second task of week number 85, and the task is called Power of Two Integers. You are given a positive number n. Write a script, positive integer number n. Write a script to find if it can be expressed as a to the power of b, where a is bigger than 0 and b is bigger than 1. Print 1 if you succeeded, otherwise 0. Right, so yeah, so simple. So this input number 8, and here's the output. Of course, definitely there are some cases when you, for example, like 16, you can like 4 powered to the power of 2 or 2 to the power of 4. So there are more than one one possibility. Right, so let's look at the solutions, and yeah, so I believe it's also quite a straightforward task. So yeah, what I'm doing here, I'm reading the number from the command line, or I take some default number and I scan all the integers up to n. Actually, yeah, it's a bit, it's not quite optimized, but I just scan all those integers, and I scan the matrix, right, where we have all those integers, like the multiplication table, and I take these two numbers. Note that parentheses are really important here, and after that I print the result if these numbers are good enough. So okay, Raku Raku 2, and the input number 8 was there built in, and for example for 16 there are 2 cases. Right, yeah, and probably I don't print 0. Right, I don't print 0, but nevertheless. Right, okay, Feng Chang, rock number 2. So we take the number, yeah, for the input number 1, the result is 1. And for other bigger numbers, so what we do, we just scan again the thing, but yeah, so the first number b is scanned from 2 up to n, but what's this? So yeah, and after that, so if this condition is there, we print 1 and stop the program. Otherwise, in the end, if we didn't exit here, we print 0. But okay, let's look at this thing. So this is the value a, and it goes, so it's a sequence here, see, so it's sequence separator 2, 3, up to something to the power of b. Okay, so that's the last number, right? So yeah, that's the last number, and it should be bigger. So yeah, I never understand how. Well, I mean, it's not really obvious for me why did Raku chose this way to design this particular thing. So this is the thing after which we have to stop the iteration, right? Stop the sequence, and basically, yeah. So basically, we have to stop it as soon as a to the power of b is already bigger than. Yeah. So that's a good optimization, definitely. Yeah. So so simple. So Raku Feng Chang Raku Ch 2, and again 16. Yeah, it's it's number 2, it's 1, and 161, it's 0. Right, yeah, of course, you see, so it's a bit faster than, well, it's notably faster than mine, because mine is not really an optimized thing. Right, okay, Jan Krnavik, rock number 2. So here's the thing, so we start here, and again, plus so means print 1 or 0, depending on if this is true or not, well, if this is true or not, and right, so, and we pass this to the power of 2 function. So we scan all those numbers starting from 2, we map those so that right, so I believe this is the okay, so n to the power of 1 divided by this y, so basically square root, right? And take until, right, then we take the map last if dot value, what is dot value here, is 1, and we take this number, and after that this number, so yeah, the value is this one, and right, this is like 2, 3, 4, 5, and this is the square root. Well, it's not square root, it's the root of power, right? If this is 1, we stop it. When can it be 1? Round. Okay, so as soon as we reached like 0.5 here, right? And if this to the power of the key is n, then we take it. Okay, I don't understand exactly how it works. Raku 1 bash Raku 2, but I believe test case is passed, and we can take the number 16 here, or 16, 15, and 161. Okay, well, yeah, the program works. Good. Kangman Leo Rock number 2. So here are the lines of the code. So the main thing, so we just immediately scan the command line and convert those values to integers and pass them to the, so yeah, this program will work for more than one input integer. Right, so this is the square root, so we scan the range from 2 to square root of n, and we take the first thing and floor of that. Why do we need floor? Of, wow, if n is n, the placeholder, the first thing, the first passed argument, actually, yeah, because it's used twice here, it's a really handy thing, to the power of n logarithm of that. Why do we need logarithm here? Okay, but okay. Raku, Goog, Raku 2, 16, 15, 161. Right, so this is condition. So on the right side, like here, right? Logarithm. What is n here? N here is, yeah, it's kind of similar to the previous solution that we saw, but yeah. Okay, good. Mark Anderson, Raku number 2. So yeah, I believe these are the test cases, and so unit log. So for all the pairs, we test the result of this function, right? Yeah, pair the key, which is this one, and pair value, which is this one, right? Okay, so the function unit int log returns 1 if this is already 1, and otherwise, again, so we scan it up to the square root of n, which is great. Again, logarithm. Wow, oh my god. So people use mathematics, yeah. And so we map that to this one, and after that dot narrow, yeah, Raku, no, docs Raku. So narrow, I believe, narrows the number, right? Returns the converting the narrowest type that can hold it without losing precision, right? Right, and if, wow, and it really works. So we try to narrow it, and we managed to narrow it so that the result is unsigned integer. Then we take this number, right? Okay, after that it's true and false, and 0, 1. Okay. So yeah, so logarithm of with this base is basically, yeah, basically we don't have to, yeah, now I understand actually the previous solution as well. So yeah, if we manage to find that this is an integer, basically it means that we found, basically after this narrowing, we've got that that second integer, right, that we want, right, in the loop. Yeah, because if we go back, yeah, here again, yeah, so n to the power of that second number, yeah, floor. Okay, right, so Mark Anderson, so let's run this program. Raku Mark Anderson, Raku 2, right, all the things. And can we input something? No, probably. Oh no, we can 16, 61, right? Okay, yeah, okay. Yeah, definitely this solution works faster, because for this number, yeah, which is, well, especially for this number, which is really big, so yeah, my direct approach will definitely work really slow. Okay, Simon Proctor, Raku number 2. Right, so in here is just technically works, but it's overkill. Yeah, that's cool. Yeah, I like this. That's actually, yeah, that's the Rakuist first thought. Just cross power, how do you call it? those ranges, and if any of them is n, then you found it. But otherwise, so yeah, we just scan the things, and if we found that, right, and and we test the next number. Okay, so yeah, that's to skip the, so basically, yeah, so either you can just make kind of square root or root of some power of some base to limit the maximum range here, or you can just already test. Probably the only thing that can be optimized here is just to use the constant for this a to the power of b. But yeah, okay, good. Raku, Simon, Proctor, Raku, 2, 16, 161. Right, that's good. Stuart Little, Raku number 2. So right, and here we see what was there in the previous solution, but commented out. So we scan that range. Actually, not exactly what we saw there. And after that, we just take this number to the power of the second number. By the way, so it's, instead of this, you can use just dots, right? It would be much fancier, or a little bit fancier. And if it's equals to n, okay. And after that, what we're doing here, okay, we are doing some, basically this QQ. It's a string interpolation, and just to nicely print the result. And how do we reach there? We reach there by calling the function, right, by getting the parameters and converting those to integer, actually the first parameter only. Raku, Stuart Little, Raku, 2, 16, 161. Yeah, so you see, so here we only have one result, while actually there are two possibilities, yeah, but the task doesn't require that. Good. Okay, going next. Arne Sommer, rock number 2. Right, so we take the number, positive number, factors repeated. Repeated. That's the method, and I kind of never used it. It creates a supply that only provides repeated values as defined by the optional. Okay, so yeah, so if there are these, and we've got A, B, B, C, and they also repeat, right? But yeah, because it's LC, so this is why capital C is here. But why do we have 2B here? Because of that, or what? Probably yes. Okay, right, nevertheless, so we want repeated factors, so, and the factors is the function that, I believe, factorize the number, right? So it's prime, candidate, and factors push if the number is divisible by this candidate, and we divide it further and repeat the loop until right, and we only pass the prime factors, right? So these are the prime factors of the number, and then we keep the repeated numbers. And okay, if there are some repeated numbers, that means that, okay, so that's another mathematical trick. So it's not a straightforward solution, it's using some idea. So if there are repeated, if there are, but what if, like, we have 2, 3, and 3, 2 and 3, no, they are not repeated. Okay, so yeah, in the repeated we'll only see if there's at least one factor which repeats, right? In this case, it's already the okay, right. Raku, Arne Sommer, Raku, 2, 15, okay, 16, and 161. Right, so the result is correct. Athanasius, Raku 2. Right, so we input some number, positive defined number, and we try to find the power, and we return a couple of values, right, from there. Find power, positive integer, and returns a list of unsigned integers. So what we do here, root multiplied by root. What is root? Oops. So we find the square root first, and after that we take it to the power of 2. And if this square root is already found, then we decide that the base and exponent are these. Yeah, basically that's the number which can be represented by a square of some smaller number. Otherwise, if that's not possible, if it's not a square, then we try to loop every second number starting, ending with this, and right, log, multiply, and finally. Okay, so that's the similar thing with logarithm, right? But it's just logarithm of 2. No, so 1. Okay, yeah, yeah. Okay, and after that, so we kind of found. And what else if we found if base is 0, output is 0, otherwise we just print this. Okay, Raku Athanasius, Raku 216. Yeah, this is the option. 15 is 0, and 161 is this one. Okay, good. Colin Crane, Raku number 2. What we do, we take the input number, and there's some big default, which is really good, 7 to the power of 7, and we scan the numbers from 2 to the square root of the input number. The test number $try, we copy the input, and if the input number is divisible by try, and so if this is divisible by try, if it's not, then we divide it by try, and continue until we can find a divisible number, right? Copy, yeah, and if we reached 1, we print 1 and stop it there. Raku, yes, so many different methods. Colin Crane, Raku 216, 161, everything works. Jaldar Vyas, Raku number 2. Right, so we've got the number from command line, and we call the function isPower, and if the number is bigger than 1, then we scan those numbers from 2 to the square root of number, and we take this power, and if this power is less than this, and if the power is already positive, then we scan the thing. How can it be 0? One of those is 0, right? So m is 0, but m is not. Okay, nevertheless. Or do we... okay. No. If this power is n, if the number, we take it, and we repeat it for... Okay, so we will probably find more than one variant here, right? Raku Jaldar Vyas Raku 216. It's 1, but we never print it, right? Why do we need these results? Yeah, actually these results are never kind of used. There's some push, there's m hat n, there's a string here, but we just count the elements if there's one or there's none. All right, okay. Julio de Castro, Raku number 2, and so many test cases, and the main function power of ints. So we take the first argument from command line and convert it to the integer, and then this function starts. We scan the range from 2 to half n. Yeah, so basically it's kind of square root, but more easily computed. And we take the first thing, the first number, which is divisible by one of these numbers, right? And then if you found that, and if this is the power, again the same formula. So if this found number, the number here, by which we could divide the input n, so we take this number to the power of logarithm n with that base, right? And round. So yeah, okay, yeah, maybe on paper it will be with proper mathematical notation, it will be easier to grasp, but here, especially with round, Raku Julio de Castro Raku 216 161, and without this, right, all this, see, so this one took a bit longer, but it did the job, right? Okay, good. Going next, Lorraine Rosenfeld, Raku number 2. So find power, we take the number from command line, we convert it to integer, and there's some default value. Find power, return 1 is number is 1, trivial solution, right? And then the out loop, so from 2 up to the square root of the number and this base, and we take it to the power of exp, which we start with 2, return 1 if this power is n, and we repeat the loop if power bigger than n, and we increment the thing. Okay. Alright, so let's run this solution. So Raku, Lauren, Raku, Ch2, and right. Oh, it doesn't work because, so if we will pause this, yeah, okay, so basically, yeah, this 15 should go actually somewhere here in between, before the dot. But nevertheless, so it should work, I believe, right? So everything is correct. Okay, good. Moving next. Jon Jung, Raku number 2. And here it is. So here's the solution, really good solution, really big solution. Right, so what's here? So there's the main function for 1, and we return just 1 because it's just 1, well, squared. For bigger numbers, input numbers, there are 2 other functions. The alternative solution, if we will pass this log, I believe, right? Using logarithm, right? And just regular solution. The regular solution, if this is a prime, we just do nothing because it is a prime. So, right, we cannot present it as a power of something to something. Otherwise, we find the largest factor. What is the largest factor? Where is the function? Here it is. So yeah, it's square root basically. Okay, and it's integer, right? So it's like floor. And after that, so we've got this sequence. We start with this largest factor and we go down to 2. Sequence can go down. After that, we lazily map these two to this pointer block, and we take the first of that, and after that, so we just print this, and we also use this nice function to just print those superscripts as the power value. Right, but before that, what we do here, so we have here an interesting construction with the triangular reduction operator with multiplication inside. Is just regular multiplication, and what we have here is actually, it's an interesting construction. So if we will do it like this, and for example, so what we've got here, like 5 dot sequence ending with infinity, and like take the first 5 elements. So here we've got the same element. I believe that we can reach the same by just using this one, right? Like this. Yeah, it's exactly the same. Okay, right. Then we lazily, okay, we skip the first one. We don't need a to the power of 1. We take it as keys and values, basically the indices and numbers. After that, wow, that's beta and kappa Greek letters. If, yeah, I don't know where the power comes into. Oh, yeah, they're here. Okay, I understand. So, yeah, basically we map those. So it's an index, and this is the value, I believe, right? So one of these. And if this is the one we need, if it's n, then we do something as beta is as beta value. And after that, we stop that. And yeah, okay, and the alternative solution is using some same construction with logarithm. So we lazily again map the same sequence starting from the largest factor, basically the floor of square root down to 2, and if so we take the first, which where the denominator is 1, basically, yeah, basically where the logarithm to that base is so is the same, is an integer, right? Okay. Raku, Jon Jung, Raku Ch2, like 15 is 0, 16 is 1, yeah, as 4 squared. Actually 2 to the power of 4 also works there, but yeah, 2, 5, 6, for example, what is it, 16 squared. Okay, interesting. I think it's a bit big, but nevertheless it works, and actually there are 2 versions there. But the interesting thing is that, yeah, for example, you can use sigil-less variables, and you can also use Greek characters as identifiers. Right, okay, next solution, Roger Bell West. So 3 test cases, and PTI function, which takes the integer, again, logarithm, and we scan the range from 2 to the square root, and this candidate, and we take the floor, and if this is the power, and we test this one and the next one. So basically we take floor and sail, right? And if one of those give us the combination we need, we return 1. Okay, Raku, Roger Bell West, Raku, Chair 1, Chair 2, sorry, 15, and, yeah, there's no. So the test cases are 8, 15, and 125. And this is 1, this is 1, and this is 0. Okay, seems to be correct. And finally, Ulrichrica, another interesting solution, I believe. So yeah, so let's a bit highlight that. So like here. So what we've got here, we take the command, the number from the command line, we upper limit, define the upper limit as the floor of square root. Okay. After that, we scan up to that limit, and we take the exponent. We started with 2, I to the power of exponent, and then we try to increment the exponent, right? And if we reach this number, we print it. I wonder if we will ever stop this loop. Yeah, definitely. So if power is less than n, while power is basically the result of taking the power. Okay, right. So, and finally, we define this flag, kind of, which we print in the end. Okay, Raku, Ulrichrica, Raku, 2, and for example 15, 16, and 161. Okay, maybe a bit more, 2, 5, 6. Right. Okay, that was it. That was the, what was that? That was week number 80, 85, right? Perl Weekly Challenge. What was that? It was week number 85 with the task which was called Power of 2 Integers, and there were Raku solutions. So thanks a lot for watching. I hope you will come again next week for another review of Raku solutions.